Hello guys, welcome to another video about LP3 practical exams. As you know, the SPPU LP3 practical exams has the following programs. In this video, we will be covering the second program for the blockchain technology section. Let's just read what the program actually says. Write a program in Solidity to create student data. Use the following constructs, structures and arrays, and deploy this smart contract on Ethereum and observe transaction fee and gas values. Let's start coding now. This is RemixIDE. As seen in the previous video, we'll just create a new file here called studentdb.sol. Let's just start with the basics. We'll first write a pragma version and the license identifier. And now we will move on and create a smart contract by the name of student data. As in the program, they've asked us to make a smart contract. As per the requirement of the program, we will now create a structure called student. Now it is also worth noting that for this current program, it doesn't make any difference whether the struct is defined inside or outside the class. But defining it inside the class restricts its scope, which is what we need in our case, as we do not have any other contract that uses this struct. And you can also brag to the examiner that my code can't be hacked easily for like brownie points because it's encapsulated, right? Students will be the object array of the student struct, and we will add a mapping called underscore roll exists just to ensure that no duplicate roll numbers are entered. Now, a mapping in Solidity is the same as hash map or dictionary. That's how it's actually implemented in Solidity. The owner is the address of the owner's wallet, which we'll write now. Then let's write out our events now. If you don't know what an event is, they are basically logs emitted during any transaction and are stored in transaction receipts, which are cheaper compared to storage on a blockchain. Student add is an event that is emitted when a new student is added to our array of struct, that is students. These are the parameters for the event, name and basically roll number, which we'll emit along with student add, because you can uniquely identify a student using these two parameters. Now, only owner is our modifier. We've actually covered this in detail in the previous video, so watch that. But basically what a modifier does, it like adds a constraint to our function that only owner can perform this given function in our case. Now we'll write a constructor to initialize the owner's address with a global variable called msg.sender. Now we'll write a function to add a new student to a student's array called function addStudent. The parameters string and class have a keyword called callData before them, as dynamic types must specify the data location as well. CallData is basically a data location. What callData does is it uses transaction data into the function and it handles it such that the data is read only, so it can't be tampered with. So, you can basically tell your examiner that your code is not affected by any malicious process, as you literally cannot even change the values that you're getting. And we will also be using a keyword called external, which will reduce gas usage compared to other options such as memory and storage. This is just in case of the parameters, right? We will be actually using memory and storage later in our program, but these are our parameters, and for the dynamic parameters, we have to use call data. I actually should probably write call data in front of the class name as well. Yeah, I got an error just because of that. External is what allows us to use call data, and only owner is our modifier. Now we'll add some validations for name and class name. Basically, we don't want anyone sending out empty fields to us, right? So we'll just use this. The bytes function has the length attribute, which we'll be using. The same goes for this thing, class name. They're basically strings, right? So you can use this function for that. We'll just say that it's an invalid, invalid name or class name. I think that's the most appropriate one. We'll also have to verify the age of the user, right? So now we'll do the same thing, require a statement for this, and the condition will be age is less than 0, obviously. Sorry, greater than 0. Uh, and in my case, I'm actually putting an upward limit as well, because I mean, your age can't be greater than 150, right? If you're a human. So just for better error handling, I'm putting that so that no one messes around with our program. We'll just say invalid age over here. And now we have to check roll numbers as well, because roll numbers can't be duplicate. Also, this error which is showing right now, there's no need for worrying about it. We just haven't used the parameters, right? So that's why the yellow lines are showing up. Let's just write the validation for roll numbers. You might remember we used a mapping, or we defined a mapping just above called role exists. So we're using that over here to understand whether the given roll number is existing in that dictionary or hash map or not. If it does exist, that means that the roll number is duplicate. So we'll just say that roll number already exists. And now we'll create a temporary object called temp students to store these values, these parameters that we are getting, and then we'll push them into our students array, which is the array of the struct. Yeah, so student, and then we'll create a new object for that, where we'll have name. Oh, it's supposed to be equal to, my bad. So it's colon, not equal to, and we'll basically name it age, class name, all the required fields, we'll name them. And as you can see, the yellow lines are gone now. So that was the sort of message that since the parameters were unused, and that's pretty much it. Now what we have to do is we'll have to update our first of all students array. We'll have to push this into the students array. Then we'll have to update our roll number, like the role exists array. Sorry, not array, the mapping or hash map. We'll just say true for that given roll number, and we'll emit the student add event. That means that basically student has been added, and this will be registered in our terminal. This will show up as the terminal logs. Also, in the above function, memory was necessary because we basically created a copy of the student object using the name and other attributes. Right now, I'm just writing a getter function for getting like the total number of students. It's quite similar to what we've done in the previous program, so there's nothing much to explain. But yeah, now we'll create another function called getStudent. So in this program, what we want to basically return is take the index of the student, and we'll return all the student details. Now, this is not really necessary in this case because if you see in the program above, we declared students as public. In case you are not doing that, you might want to declare this function, but we're declaring it anyways just so that we can learn how getter functions work for basically objects where there's multiple return types. multiple values to be returned. So in the bracket, you'll just write all the values that are going to be returned. So we have string memory, which is our name. Then uint256 is going to be the age. String memory, the second one is the class name. And the last one is going to be the roll number. Now, over here, first of all, we'll validate the index. Obviously, if the index is greater than the length of students, then that's a problem, right? Also, one more thing which is important over here, the roll number and the index, they are two different things. I'll explain why they are different in the future when we test this program. But just know that index and roll number are two different things. And yeah, that's pretty much it. I'll explain later once we're testing. So it's more intuitive that way. But yeah, now we'll return another object. Oh, sorry, I actually have to create an object for this before returning. So we'll create an object of the struct student. Over here, storage keyword is basically a keyword which points. It basically creates a reference variable of all the objects that we have received, which directly points towards the blockchain. So what we're doing right now is we're not creating a copy of like the object. Each field of student directly points to that given value in the blockchain. So we're basically saving our gas and costs by directly showing contents of the blockchain. This is the cheaper way of doing it because in the real world you will be charged for each and every transaction. So yeah, you'll have to return s.name, s.age, class name, and roll number. That's pretty much it for the program. Yeah, we've completed our program. Now, one more thing about the RemixIDE. You can see in the left hand side the green badge. It means that there are no errors while compiling. We'll just compile it again so that everything is ready before we deploy it. Now there are two ways for deploying the contract. One is using the RemixVM as an environment and the other is using Metamask. We'll first be doing the RemixVM. You basically go into environments, choose RemixVM, which will already be chosen by default. We click on the deploy button and as you saw in the deployed contracts, the this smart contract gets deployed automatically. You can see in the terminal the green like confirmation icon is present. You can now do your magic and test it any way you want to with all types of inputs and stuff. So as you can see, you have your uh, different fields: name, age, class name, and roll number. So I'm just entering random stuff over here right now and we'll transact. And yeah, as you can see, our program is working. You can see the logs where the data is clearly written. So this is it. I mean, you can go ahead and check all functions one by one. Now we'll take a look at deployment using the MetaMask wallet. First of all, you need to install the MetaMask web extension from the Chrome Web Store. This is also a way of deploying your smart contracts, which may be asked in the examination because it's technically a part of the syllabus. So I'm just opening this from the web store. I've already installed it. What you have to do after installation is log in, create your credentials. Now that once your wallet is created and you've signed in, this is how it will look like. Right now, search on the web for Google Sepolia Faucet. As we are going to be using an Ethereum based testnet blockchain called Sepolia, you will have to paste your wallet address for the Ethereum network on this page over here in the wallet address. So click on your MetaMask browser extension. As it loads, go to the menu over here. Then click on account details, networks, and Ethereum. Copy this code. Now this is your wallet address. Now click on get 0.05 Sepolia ETH. Now this may take a little time, but once it's done, you can see over here and verify the payment. Now that the tokens have been deposited, head back to RemixIDE and on deploy and run transactions, select environment as Sepolia testnet Metamask. Now, if you are trying to do it using injected provider Metamask, this may not always work and you may get an error saying that you have insufficient funds. In case Metamask doesn't show up for you, please refresh your tab. It should appear as long as your Metamask extension is enabled. Over here, after taking injected providers Metamask, it prompted me to connect my Sepolia testnet to this thing. So now it will ask me for confirmation. So I'll just click confirm over here for the Sepolia ETH. ETH over here is for Ethereum. So we are on Ethereum, just on a testnet of Ethereum. And yeah, in the deployed contracts, it should appear soon. Also, please note that try to do this process for MetaMask in Chromium-based browsers or Firefox. Don't try it in Safari and other lesser used browsers like Edge. No offense, obviously. Right. So as you can see, our transaction has been completed. I mean, we have deployed our smart contract now. We can insert students into this thing now. So I have entered data into this right now for a student at random, and I'll just confirm over here. Now just know that for writing values to the blockchain, you will always incur a cost. And the way we've written the program, we actually don't incur any additional cost while we are retrieving. So that's a good thing about this program. So over here you can see the status of the program on Etherscan Block Scout. In the logs you can see that you've actually written this, and yeah, it's a success. While we test this, there are a few reasons why the roll number cannot be the index. First of all, roll numbers are not sequential. So if you have roll numbers 1 and 100, you will have 98 vacant spaces. Then roll numbers can be really big. For example, 41101. That roll number would require us to have at least 4,000 entries before it, right? And you can't reorder roll numbers like this. So those are the reasons why. There are ways you could theoretically do it, but let's just keep our lives simple and sane. Also, FYI, RemixIDE is AI enabled. Now, an important note, I do not condone unfair practices in any way. Learning is never wasted, but that's a good feature in case you unfortunately forget the syntax for solidity. You can choose models and you can ask it to correct your syntax.